I am going to record on this computer. Here we go. Over to you.
Okay. Well, good afternoon, everyone, and thank you all so much for being here. It's really a pleasure to be able to kick off the first ever Women in Network Science seminar, and many thanks to Alice for making this happen. She had the idea for it and has really done all the work to make this happen. So since this is the first WiNS seminar, I did want to take the opportunity to start by talking about WiNS and why I think this group is so important. I have been reading recently this great book by Catherine D'Ignazio and Lauren Klein. It's called Data Feminism, and I really recommend folks check it out if you have a chance to. It's really good. But when I was reading it recently, I was really struck by how they describe their charge. Channeling bell hooks, they write that data feminism is for everyone. It's for people of all genders. It's by people of all genders. And most importantly, it's about much more than gender. Data feminism is about power, about who has it and who doesn't. And similarly, I would argue that Women in Network Science is about power. The group's formal charge may be focused on gender and specifically on women, but my hope is that everyone who is here today will make a personal commitment to working towards a network science community where every person's voice matters, where people of all genders, races, sexual orientations, and economic backgrounds, where all people are welcomed, mentored, celebrated, and given platforms to share their work and ideas. So to that end, today I'll make the following commitments to all of you. Here's my contact information and some things that I might be able to help with. Please do feel free to reach out, especially if you're a scholar from an underrepresented population, and I will leave it to you to define what underrepresented means. Also, before I start, just a quick ad. David Lazar, who's been one of my advisors at the Network Science Institute at Northeastern, is hiring a postdoc to work on social media and misinformation, looking for somebody who does a lot of computational work in particular. So the main information is here, but please feel free to reach out if you have any questions or if you're thinking about applying for this. So with all that being said, the work I'm presenting today is called The Structure of Reasoning, or if you prefer a more formal title, can we measure individual variation in how people structure their opinion, political expressions, and do we really care anyway? Now, there's a lot in that question, so let me break it down a little bit. First, this talk focuses on the structure of people's beliefs, or more precisely, the linguistic structure of how people talk about their beliefs. Specifically, it looks at these expressions on an individual rather than collective level. Furthermore, this work aims to develop new methods appropriate for measuring this structure and argues that this inferred structure is a subject worthy of study. Now, a quick spoiler alert, my answer to this question is yes. Now, I do also want to be clear that this idea is not new. Indeed, there's a classic line of scholarship that has argued that the distinctive ways in which individual, everyday people talk and structure their political beliefs is an interesting behavioral matter in itself. Unfortunately, this line of work, which relied primarily on in-depth interviews and hand coding of texts, it was very difficult and time-consuming and was largely abandoned as modern mass polling became much more efficient. But what's really exciting is that we're currently in sort of a golden age of computational social science. And the tools and methods that we have available to us today make this task tractable in a way it never has been before. So really this work is about trying to re-examine this classic line of work and arguing that this is something that we should really invest more time and energy into looking at and developing methods for. So the basic argument of this work begins with the idea that political reasoning is structured. So when we think about politics, there's some cognitive and linguistic processes, and these are connected in some way, and they both have a network structure. So processes of remembering and learning have a network structure as we store and retrieve information based off its connections to other information. And also processes of arguing and justifying have a network structure as we use connected ideas to defend or rebut an argued point. And it is meaningful that these opinions are structured. There's a long line of work in moral philosophy that has argued that good reasoning must be coherent. And philosophers disagree widely on what sort of coherence should look like. And here we can see sort of a couple of different examples of what coherence might look like in terms of actual network structure. And I'll note that the words that I'm using to title these concepts, the connectivity, complexity, hierarchy, they're intended here to be more colloquial uses of those terms and not in the technical network sense. But we can think of them as sort of connectivity as sort of a baseline condition for coherence, also complexity, following Dancy's idea of particularism, that life really is complex, and that in order to make good moral judgments about a situation, you really need to understand sort of the specific context that you're looking at. And then the last one I call hierarchy, and this follows Sidgwick. And the idea here is that some moral arguments really are central and should therefore enjoy sort of a centralized place within your sort of cognitive or conceptual network structure, that there are sort of these core ideas that you should always come back to when you're trying to make a decision about something. And I do also want to be clear that this is not to say that structure is the only thing that matters. Indeed, especially if we're talking about something like politics or political opinions, then the nodes, what people actually believe, is arguably more important. But there's already a lot of great work that's looking at sort of the contents of people's beliefs, and there's not very much work looking at the structure of those beliefs. So this work intentionally looks at the structure separate from content in order to sort of interrogate whether there's meaningful signal within that structure itself. So in order to infer this conceptual network structure, we have to start with the classic questions of network science. What are the nodes and what are the edges? So roughly speaking here, the nodes would be concepts and the edges would represent connections between those concepts. So to be more specific about this, we need to first think about what we mean by concept. So a concept can be considered as a compressed representation of information, or sort of collection of related things. Put more simply, a concept is essentially a list of related words. So if I ask you to explain to me what social distancing means, you need to use words and sort of describe it in terms of words that I would know. So operationally, we can sort of identify these similar words by using pre-trained word embeddings. So essentially, words which appear in similar contexts are considered to represent the same underlying concept. A little bit more formally, we can consider words as sort of these high-dimensional objects, and we can embed them in a high-dimensional space in such a way that words which appear in similar contexts are geometrically close in this high-dimensional space. So to give a brief example of this, imagine that I see two sentences. I took my dog to the vet, and I took my cat to the vet. Now, if I don't know what a dog or a cat are, I might imagine that they're similar things from these sentences. But if I see some additional sentences like, my dog plays fetch and my cat likes to sleep, I might start to think that dog and cat are quite similar as I initially thought they were based off those first two sentences. But then if I see another sentence like, I never go outside, then even if we don't know what sort of outside means, I might start to get the sense that dog and cat, while different, are also more similar to each other than they are to this concept of outside. So imagine doing this with a large corpus of English language text. You could do it in other languages as well, but sort of same language texts. And you can essentially learn which words are more similar and which words are less similar to each other. So sort of bringing this back to the network setting, each node in our inferred networks will represent either a word or a collection of similar words that are used by a subject while expressing their political opinion. So if concepts are essentially words, then next we need a mechanism for identifying the connections between those concepts. And interestingly, this is actually sort of built in through language. So in fact, grammatical structure is designed to encode implicit connections to indicate to a listener what ideas are connected to what. So take this sentence, for example. Bodily autonomy is a basic human right. And when we look at the grammatical parse of that sentence, we see that there are these two core clauses which are each connected to grammatical structure. So the words in the clauses themselves are connected by short arcs, where it's an adjective, in this case, adjectives modifying nouns, while those clauses are then connected by longer arcs, by sort of the grammatical sinews that make a sentence hold together. So through this grammatical structure, we can actually see sort of the different concepts that are being raised and how they're connected to each other. So to be a little bit more specific, in order to infer this conceptual network structure, I go through 4 steps. So the first, given a text, is to infer the part of speech tags and determine the grammatical structure of that text. Second is to turn negative words into negative ties. So if somebody says something like X is not Y, that would be considered as a negative relationship instead of a positive relationship. Also removing stop words while maintaining network structure. So this will drop words like a and the, but still sort of keep those core meaningful words connected to each other. And then finally, going back to the step in word embeddings, looking at sort of which of these nodes or words actually represent the same concept and then merging those nodes together. So if we put all these steps together and apply this approach to pieces of text, then we get something that looks roughly like this. And I'll tell you a little bit more about these specific networks in a few minutes. But you get weighted signed networks where the grammatical structure sort of captures which concepts are connected to which other concepts, and the word embeddings capture which words are relating to the same concept. So the next thing we need to think about is how to sort of measure similarity between these networks. So as we can see here, the networks are of different sizes, they have different nodes, so it's non-trivial to think about what it means to compare them. So what I do here is actually just use a set of 7 different network measures. And the idea here is that some of these measures capture sort of different dimensions of the topology of the network. So I'm less interested in thinking about like, does network A and B, do they share the same nodes, and is there an edge between those nodes or not? Again, the point of this work is primarily to look at structure separate from the content itself. So looking at sort of the specific topological properties of these networks. And there's a set of these, so density, average degree, and clustering sort of get to this complexity idea of coherence, of are people interconnecting the things that they're thinking about. The giant component gets to the connectivity, so this is the percent of nodes that are in the giant component. So seeing whether there's sort of disparate islands of beliefs that people are bringing up, or whether sort of everything's connected in some way. And then hierarchy, or sort of looking at how heterogeneous a network is, looking at the entropy, disassortativity, and the standard deviation of the average degree. So I'll apply this method to 2 distinct data sets. The first is an original study conducted through Mechanical Turk, in which subjects were asked to respond to 2 of 3 political prompts. Subjects also completed an extensive demographic and personality survey. The second data set was collected by Dan Hopkins and Hans Newell, who very graciously allowed me to use their data set for this. And they presented subjects with sort of an ideological Turing test, where subjects were asked to write separate texts that described the liberal and the conservative position on a single issue. Subjects were asked to write as if they actually held that view, and were told that their goal was to convince a reader that they actually held that belief. So with the first data set, we can look at some correlations between sort of the structure of expressed reasoning and the traits that were identified between subjects, or in a subject's personality measure, in the personality survey. So specifically, we can look at sort of the correlations between a given network statistic and a given personality measure. So if the inferred structure is meaningfully correlated with personality traits, we would expect not only to sort of see correlations themselves, but to actually see sort of meaningful patterns in that correlation. So several of the personality measures that we're looking at in the survey have been found to be correlated with each other in other settings, so we would expect to see similar things here. And that is in fact exactly what we see. So we can see here that not only are there correlations between the personality measures and the network measures, but we see sort of a striking left-right divide here, where sort of some of the traditionally conservative personality measures, I should also note this is all within the context of US politics. So some of the traditional conservative personality measures, such as purity and authority from the Moral Foundations battery, people who sort of score high on those dimensions all have like write text that have structures that are similar to each other. And then on the other side, we see that people who score high on liberal dimensions of progressiveness and openness from the Big Five, they also tend to have sort of similar network structures to each other and have sort of a shared topology. So to be a bit more specific, what these results are showing us is that the liberals in our sample, their network sort of fell somewhere between complexity and hierarchy, showing lots of interconnections and a relatively dense structure, but also having some hub and spoke likeness. And then networks for our conservative subjects, on the other hand, were much more likely to be disconnected and disparate. And I do want to note here that the sample skewed liberal. So while it is interesting that sort of the liberals in our sample and the conservatives in our sample do appear to have sort of very different topological features to their networks, it's not really enough data to sort of make strong proclamations about like what a liberal thinks like or what a conservative thinks like. So the second data set is this ideological Turing test. And with this, we can examine two additional research questions. So we just saw that conservatives and liberals appear to structure their expressions differently, but it's possible that this is just a reflection of ideological talking points that sort of, you know, if you're reading from group A's list of talking points, then you sort of say one thing, and if you're reading from group B's, you say another, and that's sort of what's driving the difference. But it could also be looking at it could also be driven by more personality traits or something about sort of individual style. So that's the first question I'll look at. And then second, I'll show that this approach can also help distinguish between sort of authentic and ironic responses, which further suggests that there's kind of that there is a meaningful signal within these network structures. So as I mentioned, every subject produced two essays, a conservative essay and a liberal essay. If network structure is indeed driven by personality traits, then we would expect a subject's essay across both ideological positions to be similar. Though if the structure is instead a reflection of ideological talking points, we would expect essays expressing sort of the same ideology to be similar. So in other words, if we look at the pairwise comparison of inferred networks, where a distance of 0 means those networks have the same structure and further distance indicates less similar structure, then we have on the vertical axis here the cumulative distribution. If we see something like this, then it means that the networks we're comparing are more similar. And if we see something like this, it means that the networks we're comparing are less similar. So we can take these texts and look at, for an individual, how the two essays that individual wrote compare to each other, and also how their essays compared to other people's essays. And we'll look at this specifically limiting it to people who share the same true ideological view. So if I am a liberal, I would compare my liberal essay to other people's liberal essay, and then my liberal essay to my conservative essay as well. And what we see here is that there is a small but notable difference where people do seem to be slightly more self-similar than they are to other people's essays on the same ideology. So this does suggest that people have sort of an individually distinctive style, which is not merely reflective of ideological talking points. Now, the graph I just showed you only includes the responses of subjects who participated in good faith in this study. So as I mentioned, subjects were instructed to write as if they actually held these beliefs, and as it turns out, only about half of the subjects followed those instructions, with the other half instead responding with sort of caricatures of an ideological view. So we're going to play a little game now, which is much harder to do virtually than it is in person. But here's what's going to happen. I'm going to tell you that either the liberal or conservative position on abortion. I'll read you an excerpt of one of the responses that we got, and then I will psychically infer whether you believe that this text was written by a conservative respondent or a liberal respondent. Okay, so here we go. So the first one is, the liberal position on abortion is, a woman has the right to determine what happens to her body. Was this text written by a liberal or a conservative? And if you said liberal, you are correct. So this text would get a coding of 1 and be labeled as an authentic response that indicates sort of the liberal point of view on abortion. Okay, here's the next one. The liberal position on abortion is, it is okay to murder. Was this written by a conservative or a liberal? If you guessed conservative, you would be correct on this. So this would get a coding of 0 and be labeled as an ironic response that doesn't appropriately reflect the view that it's supposed to reflect. Okay, moving on. The conservative position on abortion is, women need guidance from more superior men. Was this written by a conservative or a liberal? This one was written by a liberal and was an ironic take on the conservative position, so it would get a coding of 0. All right, last one here. The conservative position on abortion is, all life is sacred. Was this text written by a conservative or by a liberal? I hope I tricked you on that one, because it was actually written by a liberal, but it was written by a liberal who followed the instructions of what they were supposed to do. So this person actually made an attempt to represent the conservative point of view, and so this text would get a coding of 1 and be labeled as an authentic response. So the question here then is, can we tell sort of these authentic responses from ironic responses? And the answer is we can, and we can sort of imagine a couple of different ways we might do that. So first, for a baseline, if we sort of randomly guess, we might be right about half the time. A little over half the sample did actually participate in good faith. And so if we guess that everybody was being authentic all the time, we would be right 56% of the time. We might also think that something like word count would play a role in this, where longer responses are more likely to be authentic. And we would be right in thinking so. So if we train a model that just classifies based off word count, we would be right about 70% of the time. But then if we look at the network features, we can actually improve on that a little bit and get up to being right 74% of the time in terms of classifying whether a response is ironic or authentic. And these results are from a logistic regression. So we can look at sort of the coefficients on that to get a sense of what is actually driving these results. So one way to think about them, one way to think about these results is thinking about sort of the Aristotelian argument of what, or the Aristotelian sense of what a good argument looks like. So here we can see like word count in the model 1 does play an effect. I also looked at the Flesch-Kincaid score, which is intended to sort of capture the sophistication of a text. And that does seem to have a little bit of signal, but not a ton. It doesn't really seem to provide any information. But then when we look at the network features, we can see that average degree and density, as well as giant component to some extent, have do seem to be giving a little bit of a signal. So if we think about this sort of through the Aristotelian sense of what a good argument is, sort of a major premise followed by a minor premise, then what we're seeing in these network characteristics is that the ironic responses tend to be more likely that somebody just sort of says something and doesn't back it up at all. Whereas in the authentic responses, people sort of make a point and also justify that point in some way. Now again, because we're just looking at the structure here, there's no real way to know just from this model of whether sort of their backup point is a good point or a valid point, or whether their major point is a good point or valid point. But it does suggest that people who are sort of trying to make a good argument tend to sort of say something and justify it in some way. So I know that was a lot of methods that I just threw at all of you. I wanted to be sure to leave plenty of time for discussion and Q&A. To wrap up here, this approach does find that people do structure and sort of express themselves in individually distinctive ways, and that this structure contains small but meaningful signal, even separate from the content of the reason itself. So I personally am particularly interested in deliberation and thinking about sort of how people talk or fail to talk together about matters of common concern. And so part of where I plan to go with this work is looking at sort of how people structure their political expressions and how that influences both their ability to understand other people as well as their ability to be understood by other people. So doing that would require looking at both the structure and the content of these political opinions. But this work does seem to suggest that there is a meaningful signal just within the structure itself. So if we start to think about that and add content to that, I think there's a lot of really exciting things that we can do. So thank you very much, and I really look forward to hearing your questions.
Thank you so much, Sarah. We do have a question in the chat, and I'm just going to say, since we are a group of roughly 40 people, that if you do have a question, just raise your hand and I'll try to coordinate a bit so that we can take turns in unmuting and asking questions to Sarah. So Holly, do you want to kind of come and ask your question yourself, or should I just raise your hand? Yeah.
I was just curious if you had it in the data that it was confirmed. Just, I mean, kind of idle curiosity. Did you have it confirmed that the respondent that they were answering, you know, sarcastically or ironically?
Yes and no. So we know, sorry, I'm getting a lot of noise. So we can see, or we know what somebody's true position is. So we know whether somebody identifies as a conservative or a liberal, but then we don't know whether they would say that their response was ironic.
Okay, I got you. Okay.
So then I'm not sure whether that's we have a raised hand from Phil. Go ahead, Phil.
Hey, thanks so much, Sarah. I'm wondering, do you see any prospects for something that's like a little bit predictive in the sense where you feed it like a possible topic and then it says, hey, this kind of network is likely to emerge as a structure of reasoning, or this is implausible a structure of reasoning, or anything like that?
Yeah, potentially. I think that's a really interesting question. I think one of the things I struggle with in sort of the last piece that I was presenting here is I wouldn't necessarily say like, oh, now use this network structure to determine whether texts are ironic or authentic, because there are other tools that can do that better. And it's more, in doing that here, it's more about showing that there is a meaningful signal in there. But I do think that there is the potential that sort of some of these network approaches could be predictive in some way, or be used for predictive things. So for example, I have a project I'm looking at where I'm working on where we're looking at how gender and race are talked about in newspaper articles, and particularly looking at the framing of that. So like, are people of different races talked about in different ways, for example? The answer is yes, but trying to find sort of automated text ways of classifying sort of whether subjects are treated favorably or unfavorably. And I think that these sort of network approaches could be really helpful for that kind of task.
Super cool, thank you.
So then I'm going to take the opportunity to ask maybe one or two questions. One would be of a more technical nature, and that is, you showed these short excerpts, so these short answers that people gave that were either ironic or not ironic, and then you showed the results that you get from using the network approach on that. But these snippets of text, they're very short. So how do you get a network out of something that might just be one short sentence? Am I missing something about how that network comes about?
Yeah, so the texts overall are fairly short. The ones I showed are sort of intentionally truncated, so they're a little bit longer than that, but they're most of the texts I work with are like 50 words are the smallest ones, and like maybe 200 words for the longer ones, which is still pretty short. But there is still sort of a structure within even a short text. I mean, I guess if somebody had a sentence that was like just the word "the" over and over again, you wouldn't necessarily get a structure. And there are a few of the texts that I exclude from the analysis because they generate no network at all. But most of them, even with short text, will generate some sort of network.
So something like 200 words is enough to get a network.
Yeah.
Do you then control like how many nodes you get out of it, or does that come out of the method itself? So you just put the text in and you get a network out, and then it has some number of nodes, and you don't know before you did it how many those are going to be.
Yeah, so there's definitely a correlation between the number of words in a text and the number of nodes in a final network, but I don't control for that directly. For some of the network features, I do normalize based off the number of nodes. So like for entropy, for example, I base that off the number of nodes.
Okay, thanks. So we have like lots of more questions popping up. So I'll hand over to Adina for a bit, and then I'll read some questions from the chat.
Hi, that was so awesome. Thank you.
Thank you.
I am thinking about your discussion of like making the nodes out of concepts and how some concepts are, I think you said a singular word, and some are a collection of words. And I was just curious how you decided which to combine and which to keep separate, because I'm thinking about how that would like affect the density of the network and sort of just all of the network measures probably.
Yeah, that is a really good question. So the basic rule, and of course it's one of those things where it's like there's the simple version and then it gets like exponentially more complicated, but the simple version is there's basically a threshold. So you have two words, they each have a vector associated with them in this word embedding space, and if the cosine similarity of those is sort of within a certain threshold, then they're considered to be the same concept, and if it's beyond a certain threshold, they're considered to be different concepts. One of the things that I do want to do with this work is go back and do some more robustness checks around sort of what that threshold is. How I've done it so far is that it's, I basically did, I tried a bunch of thresholds and kind of looked at what words were being combined, was like, man, that looks good. But there's obviously more rigorous ways in which one could do that. And then also it gets slightly more complicated because there's lots of situations where you can imagine it almost as like a chain of words. So like burger might be close to king, for example, because of Burger King or something. But I don't know why I'm thinking about Burger King all of a sudden. But then like patty would be close to burger, but not close to king. So I have some more specific rules that are like, it's not just about like the pairwise comparison, but you need sort of like a cluster of words that are all similar to each other in order for them to be considered the same word. But again, I think that's a place that could use a lot more exploration.
Thank you.
Thank you.
So we have a few questions in the chat. We have one from MC Ramos, who writes, "Thank you, this was great. Can't use my microphone at the moment, but would like to ask if you had measures, if you have measured other personality measures like education, socio-demographic questions, perceptions of the out group, liberal or conservative, etc."
Yeah, so I do have a few of those things like education, race, gender. I ask in my survey, and for many of those, so there are correlations between those demographic measures and the ideological measures. So if I didn't show it here, but I have a similar plot that's sort of the demographic measures, and it kind of breaks down to like old white men have patterns similar to conservatives, and other people have, or like, you know, other demographics have patterns similar to the liberals. And it's at least in sort of the sample of subjects we were looking at, it really falls very closely along those ideological lines. I think I haven't looked at sort of outgroup sentiment, which I think would be something really interesting to look at. And I think the other thing that I am interested in exploring more is the education piece. One of the things that I guess makes me nervous about this work in some ways is that I want to be very careful about not sort of ascribing sort of the sophistication of a text to, like make normative claims about that. So I think one thing that would be really interesting to look at is sort of how sort of education level is affecting, I don't quite want to say like the quality of the writing, but like how an algorithm might judge the quality of the writing and see sort of how that affects the output networks, and in order to be sort of thoughtful and mindful about like what kinds of inferences or judgments we're making based off that.
Thanks. So the people in the chat, if you have kind of follow-up questions, then just post them in the chat and then I'll see them there. So we have another question from Joel Nishimura, who says, thank you for your talk. Have you considered looking at statements of public officials?
Yeah, that's a great question. I think that's probably a place that I will go to soon, possibly next. I think what's nice about public officials is they tend to have much more text that's available, and it also tends to be very well-formed text. So like, especially if you look at something like press releases, then it's sort of has a format that is, most of the sentences will be like grammatically well-structured. Possibly not the same for extemporaneous speech by all politicians, but I think it could be a really interesting place to go with this. I personally am primarily interested in thinking about sort of how everyday people talk and reason, but it's, I think, much more difficult and also much more fraught to try and get and analyze data on that front. So I think that looking at sort of public officials and sort of differences, like if there are sort of party differences in Congress, for example, I think would be a really interesting thing to look into. So thank you for that question.
So following up on that, I'm going to insert myself once more. One thing that I really liked was when you looked at the similarity between people themselves and kind of the ideological standpoints, and saw that there was different cumulative distributions of network similarity, right? So I was wondering whether you can use kind of this framework that you presented to kind of look at things as, to what extent are the things that I write when I write about my political opinions, things that I came up myself or that kind of reflect my personality, rather than just me repeating talking points from the news that I consume. So essentially doing something like comparing the network that you get by looking at certain news outlets versus the people that might subscribe to the same opinion.
Yeah, that's a really interesting question. Yeah, and I think it ties back well to the last question of thinking about sort of like, who are the opinion leaders, whether it's specific individuals or news outlets or something, and seeing what sort of messages get passed along. With that, I do think it would be interesting to sort of look at the structural aspect of it, but I think the content piece might be even more meaningful there, where it'd be interesting to see sort of if there are specific, not just words, but specific phrases that sort of get passed along.
Thanks. So we have another question from Doina Bukul, which I probably didn't pronounce correctly. I'm sorry. What's the plan with regard to adding content and semantics? Would it be really it would be really interesting to have networks with semantic node attributes, which you then can compare.
Yeah, so this is one of those things where I keep being like, that's future work, but I am really interested in thinking about it. One of the challenges is that it's really non-trivial to think about how to bring those two pieces together. So at the basic level, there's sort of a question of like, so if I have two networks, if they both have the same node in them, can I consider that sort of, or like if they both use the same word, can I consider that the same node in terms of comparison and use that for sort of semantic comparison. But also, so I've done this exercise with undergraduates where I have them like write things on Post-it notes and like make a conceptual network for themselves. And the first time I did it, one of the things that really struck me is there were like one of the prompt questions was like, who inspires you? And so a bunch of people wrote like, my mother. So then you have these networks and multiple networks that have a node that's my mother, but it's not the same mother, right? So, so I think there's this really interesting challenge in terms of adding the semantic piece of it or the actual content of these concepts is thinking about like, what does it really even mean to compare sort of how I'm conceptualizing something with how you're conceptualizing something? So I guess that's kind of a non-answer to your question, but I do think it's a really important next step, but it's unfortunately not as simple as like, okay, send things through this pipeline and then send things through this other pipeline. I think it really relies on some sort of deep thinking to come up with a good approach to that.
Would there be some application here for things of moving from simple networks to something like a directed network or a network with node colors or multiple layers or something? Because when you were talking about the cats and dogs, one of the things that came to my mind is that what if you look at cats, dogs, and pets? So a dog is a pet, every pet is a dog. Is there like, could you construct a formalism that can entail more of that somehow in the structure?
Yeah, I think that would certainly be one good approach and one way of thinking about it.
Okay.
That's my answer. Sorry, I'm just like constantly like reflecting on this. I don't know.
Well, it's like people have so many questions and there's so many I get it. There's like so much input that you get, right? But I think people are really interested. So we have another question from Marika Wakatsu, who's writing, thank you for an awesome talk. Following up on the comment about the quality of a writing, do you know of, might it be possible to do a similar study in which participants are asked to express the different stances orally? Would you expect to see similar structures?
Yeah, also a really good question, and something that I would love to do. That's one of those like, if I had money, here's a way I would spend it kind of experiments, where I do think that like in general, I think for particularly on the Mechanical Turk study, it's a relatively small sample of people and we paid the respondents pretty well. So people actually took the time to like write something thoughtful. And like most adults can write like 100 words coherently if they are invested in trying to do so. In the other study, I think the compensation wasn't quite as much, so which is part of why that you had a lot of people just kind of giving joke answers, as they didn't have much reason to like actually give it full thought. But I think also in addition to that most people, it's much easier to sort of talk and say your opinion than it is to like try and write it down and communicate it well to somebody else. So I think what a lot of these experiments are trying to simulate is like, you know, if you're talking to your buddy and they say, hey, did you hear the news about whatever? Like what words are going to come out of your mouth? But obviously having a like survey that you're taking on your computer where you have to write it is going to get a very different type of response than if you're just talking to your buddy about it. And there's the only way to sort of compensate for that is to try and do some like oral recordings of things. So I think that would be really interesting to look at. And I think it would also be interesting to look at sort of if there's variation in that. So I personally find I tend to write the way I talk a lot of the time, but I think there's other people who talk the way they write, or like people have very different styles in terms of like how their brain prefers to communicate or process information. So it'd be interesting to look at sort of variation in that as well.
Sounds great. So I'm going to do a last call for questions. So if you have a burning question or a non-burning question, right now is the time to unmute yourself and shout. If not, then I think this was a really great talk. Thank you so much, Sarah. Thank you for everyone who participated in the discussion. And so the question that I get, when is the next seminar? So the next seminar is going to be next week. I'll send out the details. It's probably going to be the same Zoom link, and I send out the details probably today, and then a reminder next Tuesday, and then we'll drum up people on Twitter again as usual. So I hope to see you all again in a week's time. It's going to be Jess Enright who's going to present. As I mentioned in the kickoff meeting, this seminar is open for you to give presentations of your own work as well as journal club presentations. So next week we're going to have a journal club presentation, and I'll send out the paper today. There is lots of thank yous to you, Sarah, in the chat. Somebody is leaving a link to the reading group on the data feminism book.
Oh, yeah.
So that's
yeah, there's the Data Feminism Reading Group. It meets at noon Eastern on Fridays. Last week was the introduction, so this week we'll be reading chapter 1. But it's fun.
Okay, so people can still join and catch up easily.
Yes, yeah, and if you go to that link, it will have the information, and it's mostly, I think, the authors like talking through the highlights of the chapter. So if you don't actually read it beforehand, that's okay.
Awesome. So okay, so here's the link. I'm not sure whether it's going to be in the video or not, but I'll save it and distribute it. And yes, again, Sarah, thank you so much. Thank you for everybody joining. Stay tuned for updates on Twitter and on the mailing list for the seminar next week. So
And thank you so much, Alex.
Thank you. Bye.
All right, bye. Take care, everyone.